Welcome students. So today we are going to begin a new chapter in class 9, that is gravitation. So what is mean by gravitation, and what is the difference between gravity and gravitation, and what are the importance and characteristics of the gravitational force we are going to study in detail in this chapter. So let us begin this session with a story. So, what is the story behind the discovery of gravitation? So, when Isaac Newton was sitting under the tree, so he observed that apple fell on his head. So, according to his new first law, what he knows? According to first law, until there is an external force acting on a body, the body will remain in the same state of rest or uniform motion. So that means the apple is fell down. So when the apple is fell down, there must and should be a force acting on the object. So there must and should be a force acting on the object towards the surface of the earth, or towards the earth a force is acting. So that force is named as gravitational force. So gravitational force, or he also named as that force as force of gravity. So what is mean by force of gravity? So gravity means it is attraction. So attraction between the objects is known to be gravity. So here there's a lot of difference between gravity and gravitation. Let us study that. What is the difference between gravity and gravitation? So gravitation is nothing but it is a phenomena of existing the force between the two objects. That means between the two chairs, between the books, and between the wall and you. The whatever the force of attraction existing between the two objects is known to be gravitation. So then what is gravity? So gravity nothing but it is a force exerted by the huge bodies or heavenly bodies like sun, moon, earth on the objects which are present on its surface. So that force is known to be gravity. So gravity is a special phenomena in gravitation. Try to understand the difference between gravity and gravitation. So gravity and gravitation are not same. Gravity and gravitation are not similar terms. So why they are not similar terms? Gravitation means it is a force of attraction between the two bodies due to their masses is known to be gravitation. And what is mean by gravity? So gravity is nothing but it is a force between the huge bodies, and the same way objects which are present on the surface is known to be gravity. So this is the difference between gravity and gravitation. So gravity is a special phenomena of gravitation. Okay na? Now let us take a look about the how can we calculate the force of attraction between the two bodies. To find the force of attraction between the two bodies, so Newton derived a formula. So that formula is known to be universal gravitational law. So Newton's universal law of gravitation. So very famous law, and it is a fundamental law in physics. Universal law of gravitation. Sir, what is mean by law of gravitation? It is also known to be inverse square law. Sir, why it is called as inverse square law? Let us discuss in detail. Right. Let us consider two objects of masses m1 and m2 separated by a distance d. So d is the distance between the centers of the bodies not from the ends or edges of the body. Always we need to take the distance between the two bodies from their centers. The distance between the two bodies is considered as d. Now the force of attraction or the gravitational force between the two bodies according to Newton is given as force of attraction is directly proportional to product of their masses. So m1 into m2. So what is the meaning of this directly proportional? If the mass of the objects increases, the nature of force of attraction between the bodies will also increase. That means the magnitude or strength of force of attraction will also increases. And he also state one more important relation, that is the force of attraction between them is inversely proportional to square distance between the two bodies, that is F directly proportional to 1 by d square, or F inversely proportional to d square. What is the meaning of this? When distance increases, force of attraction between the bodies will decreases. One more important point, this gravitational force is a fundamental force which is exist in the nature. So gravitational force is a fundamental force, and in the same way this gravitational force is a non-contact force. So in class 8 we discussed already. So gravitational force comes under the group of a fundamental force, and it is non-contact force, and it is always attractive in nature. It never be repulsive in nature. Okay, now let us come to here. By joining these two, we are going to write F directly proportional to m1 m2 by d square. So we can write F is equals to g into, I am removing the proportional here. After removing the proportional, so introducing a constant here, g m1 m2 by d square. Sir, what is g here? So g is universal gravitational constant. Sir, what is mean by universal gravitational constant? This universal gravitational constant, wherever in the universe the value of capital G is remains constant or fixed. That means from place to place the value of capital G is never changes. Sir, what is the value of capital G? The value of capital G will be, so 6.67 into 10 to the power of minus 11. Sir, what is the unit of universal gravitational constant? So even it is a constant, it has unit. Sir, what is the unit of this? Let us try to make the subject capital G from equation number 3. So G we can write F into d square. So this cross multiplication by m1 m2. So what is the unit of force? Unit of force is Newton. And what is the unit of distance? Meter. So here meter square. And what is the unit of mass? Kg into kg. Therefore kg square. So therefore we can write unit of capital G is Newton meter square by kg square. So this is the SI unit of capital G. So we can write here. So G value is 6.67 into 10 to the power of minus 11 Newton meter square by kg square. It is a very important in doing the problems. Okay, now you need to remember the value and whatever the unit of this. So this is SI unit. Sir, what about CJS unit? So CJS unit of this is, CJS unit of force is dyne, and CJS unit of distance is centimeter square by kg square, nothing but gram square we can write. So this is the CGS unit of the gravitational constant. Okay, so what is universal gravitational law? The statement of universal gravitational law we can write force of attraction between two objects is directly proportional to product of their masses and inversely proportional to square distance between the bodies. So this is the statement of the Newton's law of gravitation. So it is a fundamental law in physics. Okay, right, now let us move to the what are the characteristics of the law of gravitation. Okay, right, so characteristics of law of gravitation or gravitation. So gravitation, I told you that already. So there is no contact between the two bodies. That means even there is a contact or without contact, there must and should be a force of gravity or force of gravitation will exist between the two bodies. Okay, na? Right. That's why simply we can say that it is a force at a distance. So what is the meaning of this? So let us take, if we throw an object from the surface of earth by giving some initial velocity u, when you throw the body vertically upward direction, what will happen? Slowly its velocity is going to be reduced, and after reaching to a particular height, its velocity becomes a speed velocity becomes 0, then again it start reaching the ground. That means even though there is no contact between the object and the earth, the force try to pull the body always in downwards direction. That is the meaning of it is a force at a distance. Okay, na? So wherever it may be, the objects, whatever the distance between the object it may be, there must and should be a force of gravity will exist between the bodies, or attraction will also exist between the bodies. Okay, right. And one more very important point here. So it forms action and reaction pair. Action and reaction pair. What is the meaning of this, sir? So that means the gravitational force is forms action and reaction force. What is the meaning of this? For suppose this is object 1 and object 2. So object 1 wants to pull the body towards it. In the same way, object 2 wants to pull the body 1 towards it. That means there is a force of attraction acting on second object due to first one. That means the first one tries to pull the body towards it. In the same way, second one also tries to pull the body one towards it. That means here there is a force acting on one due to two. So it forms an action and reaction pair. So any one of it we can take it as an action, other will be automatically a reaction. So what is action I am taking? Force acting on 2 due to 1 I am considering as action. So what is reaction? Reaction is equals to F12. So minus F12. Therefore, sorry, when there is an action and reaction force exist, so why the bodies are not sticking together? Okay, now so between, already told you, between you and wall, a force of attraction is existed. That means the gravitational force exists between you and the wall. Then why we are not sticking to the wall? Because the action and reaction both are same. Then what will be the resultant force acting on the system? F12 plus F21 is gives 0. That means net force acting on the system is equals to 0. That's why the objects are remains at the same position. So because of the reason only we are not sticking each other. In the same way we are not sticking to the walls. And one more important point, the magnitude of force of attraction acting on first body due to second one, and in the same way due to first one is also same. Therefore, the ratio between force acting on second body due to first one, force acting on first body due to second one is in the ratio of 1 is to 1. So for suppose the question is given like this. So 5 kg body and 10 kg body are separated by certain distance d is equals to 2 meter, then what is the ratio of force of attraction between the two objects? So if you know this point, we can easily attempt the question. Why? Because whatever the force exerted by 5 kg and 10 kg is equals to force exerted by 5 kg, 10 kg and 5 kg, both are same, even though masses are different. So what we are going to get, F1 we can write F12, we are going to write G into 5 into 10 by M1 M2. This is M1 and this is M2 if you take. So F12 G5 into 10 by D square is equals to 2 square. In the same way F21 if you want to write, so what you are going to get, M1 M2. So 5 into 10 by the distance is same. So what is the ratio you are going to get? F12 by F21 is equals to 1 is to 1. Without doing the problem, we can attempt the question if we know the concept very well. Okay. Now let us discuss one more important point. So the force of gravitation or gravitational force, gravitational, it is a very important point. Gravitational force is independent on medium. Sir, what is the meaning of this? Right, I will explain with one example. Two bodies are separated in air, m1 m2 by certain distance 2 meter. Mass of the first body is 5 kg and second body is 10 kg. Then what is the force of attraction between them? F is equals to, or gravitational force of attraction between the bodies, we can write G into 5 into 10 by 2 square. This is when the objects are separated in air. Now we are immersing the two bodies in a liquid. So in a liquid of density d is equals to, or I am taking rho is equals to 750 kg by meter cube, or let us take, I am immersing this in a petrol. Now 5 kg, 10 kg and distance between the bodies will be also same. Now they are going to ask what happens to the force of attraction between the two bodies. F dash is equals to how much? Okay na? So generally we thought that the density of the liquid is changes. Then what happens? Here there is density of the air we can consider as 1, and here density of the liquid will be 750 kg by meter cube. That means the force is going to affect the force of attraction between the bodies. But even wherever the location or whatever the medium present between the bodies, if the setup is same, for suppose the masses are 5 and 10 kg, in the second case also masses 5 and 10 kg, distance is 2 meter, the force of attraction between the two bodies F dash is equals to F only. That means remains same. So that is the meaning of gravitational force independent on medium. Okay na? So they are going to give the question like this also. When the two objects of masses 1 kg, 4 kg separated by a distance 4 meter, force of attraction between them is F. F1 is equal to F. Now they are surrounded by a medium of specific gravity 4. So specific gravity means relative density. So 4 and with the same distance. Then what is the new force of attraction between them? So they are going to give the option F2 is equals to 4 times of F, and F2 is equals to F by 4, F2 equals to F, and F2 equals to 0. So these are the options they are going to give. So generally with other specific gravity is given as 4, that means the answer may be related to either 4F or F by 4. So here the medium is introduced, that's why we can either check this answer with the F by 4 or 4F. But what is our main concept here? Gravitational force is independent on the medium present between the bodies, that's why it never changes. So our option will be C, it doesn't changes. Okay, so in this way we can analyze the problems based on the gravitational force. Now let us discuss some more important points related to this. So we know that according to gravitational law, F directly proportional to product of their masses and inversely proportional to square distance between them. Right, so let us take case 1. So two objects of masses m1 and m2 separated by a distance d. Now m1 increases by 4 times of the m1 and m2 increases by 6 times of m2. So this is initial mass m1, m2, and what is the final masses after increasing m1 dash, and this is m2 dash, and now they are separated by same distance. They are going to ask what is the nature of force in second case. So F1 they given as F. So how can we write F1? F1 is equals to G into m1 m2 by d square we can write. So now in this case, in second case, what is going to change? The masses of the objects are going to change by keeping the distance constant. So if the distance is constant, no dependence on distance, only depends on masses. Therefore, F2 I am going to write. So G m1 dash m2 dash by d square as it is. So because there is no change in the distance, therefore F2 we can write G into, what is the value of m1 now? So m1 dash becomes 4m1, m2 dash becomes 6m2 by d square. So 24 G m1 m2 by d square. So we know that what is the value of F? F1 is equals to capital G m1 m2 by d square. In the place of G m1 m2 by d square, we can substitute F1, initial force. Therefore, the new force of attraction between the bodies after increasing the masses by 4 times and 6 times will be equals to 24 times of the initial force. So simply you need to multiply how many times the masses are increases. So for suppose m1 increases by 2 times and m2 increases by 9 times. If the d is fixed, then what is the new force of attraction? So initial force we are going to take F. F1 is equal to, then what happens new force? The product between the masses. So 9 into 2, therefore 18 times of the initial force is going to increase. So in this way we can do the problems when the distance is fixed. So here you can write when distance kept constant but masses are changed. Now let us see next case, case 2. Now by keeping masses of objects constant for varying distance. Right, let us see. So initial distance between the bodies m1 and m2 is d. Now the distance between them is decreases by half of its initial distance. So there is no change in the masses. So m1 m2 are fixed. So what they change here, the distance. So initial distance is d1, and in next case the distance is d2 equals to d by 2. Now they are asking what is the new force of attraction between the bodies. So what they are keeping constant, masses are keeping constant. So when the masses are kept constant, the force depends only on distance in such a way that inverse square proportion to the distance. Therefore we can write f1 by f2. In case of a inverse relation, we can write d2 by d1 whole square we can write. So f1 I am taking initial force as f, and they are asking f2. So d1 we know that already d is given, and what about d2? d2 is equal to d by 2. Let us substitute here f1 in the place of f2 and d2. What is d2? d2 is nothing but d by 2 by d1, nothing but d, both whole square we can write. So f by f2 we can write d square by 4, this square, and this is in denominator, so d square get cancelled. So we are going to get f by f2 is equals to 1 by 4. Therefore f2 equals to 4f. That means what we can say simply, if the distance between the bodies decreases by n times, the force increases by how many times? So n square times of initial. So if you remember this point, you can do the problems easily. So here distance decreases by how many times of the initial distance? 2 times of the initial distance. Then how many times the force increases? 4 times the force increases. For suppose if distance decreases by 3 times, then what happens to the new force? So we know that already, if the distance between them decreases by n times, then force increases by n square times. Therefore f dash is equals to n square times of the f is a formula. At f dash, what we can write? F dash n value is what? How many times decreases? 3 times. So 3 times decreases, 3 square into f, therefore 9f. That means as the distance between the bodies decreases, the force between them will be increases by square times of the decrease in the distance. Right. Let us take one more example. Now initial distance between the two bodies is d, m1 m2. Now the distance between the two bodies is going to increase by 2 times of the initial distance. Now they are asking what is the new force of attraction between the objects. So they are keeping the masses fixed, but what they are going to change here? They are changing the distance between the object. So when m1 m2 are fixed, then we know that this force between them is inversely proportional to square distance between the bodies. So now we can write this expression as f1 by f2 is equals to d2 upon d1 whole square. So what is f1? F1 we are considering initial force between them is f. And what is d1? So d1 is d and d2 is 2d. They are asking f dash. What is f dash? Right. So f by f2, so 2 times of d in the place of d2, So in the place of d1 is d whole square. So d cancel. So F upon F2 is equals to 4. Therefore F2 we can write as F by 4. That means the force increases by 1 by 4 times, or force decreases by 4 times. That is, we can write, if the distance between objects increases by n times, then force of attraction between them decreases by how many times? N square times. That is, we can write F dash is equals to F by N square. Okay, with the help of these we can do the problems easily based on the change in distance and change in masses. Right, let us take one more example here. Now see, the object m1 m2, each mass is increases by n times. So this is n times of m1 and this is n times of m2, and the distance between them is increases by n times of distance. So distance, so what they are doing here, simply mass of each object increases by n times, and distance also increases by n times. Now let us see what happened. So what is the initial force? F1 is equals to G into m1 m2 by d square, we can write. This is the initial force of attraction between the bodies. Now F dash I am going to write as, so G into n times of m1 n times of m2. What is the value of d2? d2 value is n times of the d. So whole square we can write. So G into n square m1 m2 by n square d square we can write. So we can write this expression as n square times of G m1 m2 by d square by n square. So n square get cancelled. Therefore F dash is equals to what? So F dash we are going to get as initial magnitude of the force. That means if the mass of each object increases by n times, in a similar manner distance also increases by n times, then what will happen? The force remains same, no change in force of attraction. So this conclusion we are going to get from this analysis. Now let us take one more application. Now the masses m1 m2, now we are increasing the masses of the objects, so n times and n times. Now I am decreasing the distance between the bodies by n times. So d dash I am making as d by n, and d1 is equals to d. Now let us write first force. Force when the masses are m1 m2 and distance is d, so g m1 m2 by d square we can write. Now let us write f dash. So f dash, what we can write, g into n m1 n m2. Then what about distance? Distance will be decreases by n times, therefore d by n whole square. Therefore g into n square m1 m2 by d square by n square. We can write this as, so this denominator of denominator becomes numerator. Therefore g into n square m1 m2 by d square. So we can write g into m1 m2 by d square times of n power 4, because n square into n square base is equal, we can add the power. So n power 4 we are going to get n power 4 times of the initial force, that is when, if the distance between the objects decreases by n times by increasing the mass of each object by n times, then new force between the objects becomes n power 4 times of initial force. This conclusion we are going to get from this analysis. Okay, in the same way, by decreasing the masses. So now let's take now initial mass is m1 m2 and initial distance is d. Now they are decreasing the masses m1 by n, m2 by n times the mass decreasing, and now they are increasing the force, increasing the distance by n times. Right, so we know that initial case f is equals to g m1 m2 by d square. Then what about final case, f e dash is equals to g m1 by n m2 by n by n times, the d dash becomes n times, so n times of d whole square. Therefore f dash is equals to g m1 m2 by, so n into n square denominator, and here denominator again we have n square d square, so g m1 m2 by n power 4 d square is equals to f dash. Therefore what we are going to write, f dash is equals to 1 by n power 4 g times of m1 m2 by d square. So what is this g m1 m2 by r square? So m1 m2 by d square is nothing but what, initial force. Therefore f by n power 4, that means force decreases by n power 4 times. So these are the different cases, by changing the masses, by changing the distances, we are going to get. So the main idea of this is, so the force of attraction is directly proportional to product of their masses, inversely proportional to square distance between them. So these are the applications, so based on the Newton's law of gravitation. So in next class we are going to discuss the difference between mass and weight, and we are also going to study some more important point related to the gravitation. So thank you, stay safe.